Welcome to the Explainer. Today, we're going to jump into the Elixir programming language to tackle a problem that seems simple on the surface, but trust me, it reveals a really powerful way of thinking. Our mission today? To count some birds. So let's just imagine for a second. You're a bird watcher. You've got a notebook, and for weeks, you've been jotting down how many birds you see each day. That's great, but a notebook full of numbers isn't super useful on its own. So we're going to build a small toolkit in Elixir to actually analyze our sightings. And the data we're working with, it's beautifully simple. It's just a list of numbers. The very first number is today's count. The second is yesterday's. The third is the day before that. You get the idea. It's clean, simple, and absolutely perfect for what we're about to do. Now, as a data-driven birdwatcher, just having a list isn't quite enough, right? We have questions we want to answer. And that means we need to build a toolkit with 5 key features to really dig in and understand what's going on in our garden. So here's our wish list, our roadmap. First, we need to get today's count instantly. Easy enough. Then, we need a way to update that count if another bird shows up. We also want to know if there's ever been a day with 0 birds. Then, of course, we need a grand total of all the birds we've ever seen. And finally, we want to count how many of those days were busy days. Let's get to it. Okay, let's dive right in. We're going to start with the first 2 things on our list because, as it turns out, Elixir has a really elegant way to solve both of them with one simple but super powerful feature. And that key is a core feature in Elixir called pattern matching. Now, this is way more than just assigning a variable. It's about deconstructing data. We can literally tell Elixir, hey, I'm expecting a list, and I want you to grab the first element and call it head, and then grab everything else and call it tail. This makes it incredibly easy to work with the start of a list, which is perfect for our first 2 tasks. And you can see just how cleanly this works. If we want today's count from the list 251, pattern matching just plucks that 2 right out. If we want to increment the count for 402, we just grab the 4, add 1 to it, and then put the list back together as 502. And just like that, 2 tasks are already done. So that was awesome for dealing with the very first item. But what about our other goals? To find the total number of birds or to check for a day with 0 birds, we need a way to look at every single element in the list, not just the one at the front. And this question brings us to the really big idea that's going to unlock the rest of our toolkit: recursion. It's a fundamental concept in programming, and honestly, at its heart, it's just a really elegant way to handle repetition. So, what is it? Simply put, recursion is when a function calls itself. The real magic is how it breaks a big, messy problem down into smaller, identical versions of itself, until the problem becomes so tiny that it's just trivial to solve. Every single recursive function has 2 parts you absolutely need. First is the recursive case. This is your repeating step. It basically says, process one item, and then call me again on whatever's left. But, and this is crucial, you also need a base case. This is your stopping point. Without it, the function would just call itself forever. The base case tells the function when the job is done, which for us usually means when our list is empty. You know, the source material has this fantastic analogy for this: counting cookies in a jar. How would you do it recursively? Well, first you check your base case. Is the jar empty? If it is, the count is 0. Done. If it's not empty, you hit the recursive case. The total number of cookies is just 1, the cookie you're holding, plus however many cookies are in the rest of the jar. You just repeat that simple process until the jar is empty. Okay, theory is great, but let's see this thing in action. We're going to apply this exact concept to our birdwatching challenges, starting with how to calculate the total number of birds we've ever seen. So here's our goal. We're given the list 4, 0, 9, and our function needs to spit out the total, which is 13. Let's trace exactly how recursion gets us that answer. Okay, so first we call our total function on the full list. Now, since the list isn't empty, we hit our recursive step. The function pulls off the head of the list, the number 4, and just kind of holds on to it for a moment, then it calls itself again on the rest of the list. So now the function is just working on 0 through 9. It's the same logic all over again. The list isn't empty, so it pulls off the 0, holds on to it, and calls itself again on whatever is left. We're down to a list with just 1 item now, 9. Still not empty, so it does its thing. It pulls off the 9, holds on to it, and calls itself one last time on the now empty list. And here we are. The function is now called with an empty list, empty square brackets. This is the moment we've been waiting for. This finally matches our base case, our stopping point. And this is where the chain reaction starts to work its way backwards. And here's where it all snaps together. That final call, the one on the empty list, hits our base case and it returns 0. Now the whole chain of operations can finally resolve. The 9 gets added to that 0, then the 0 gets added to that result, and finally the 4 gets added, and we get our answer, 13. This whole process of breaking down a problem and then building the answer back up is so central to languages like Elixir, where data is immutable. You're not changing a running total, you're building a brand new answer as each function call completes. All right, let's tackle our final challenge, counting the busy days. We're saying a busy day is any day where we saw 5 or more birds. So if you look at this list, you can see there are 2 of them, a day with 5 birds and a day with 6. So the number we're aiming for is 2. Now this one's a little more complex because we need some conditional logic, and Elixir handles this beautifully with something called guard clauses. Think of it like a little check you can add right onto a function definition. We can have one version of our function that only runs when the number of birds is 5 or more, and another version that runs for all other cases. It lets us bake the if statement right into the function itself. Pretty cool. So, we've now built our entire toolkit. And in doing that, we've learned more than just a few Elixir tricks. We've actually learned a powerful new way to think about and break down problems. Let's just step back for a second and look at everything we built. You see the pattern here? For any task that only cared about the first item in the list, pattern matching was the perfect tool. But for any task that had to look at the whole list, recursion was our answer. The core idea was always the same. Define one single repeatable step, whether that step was checking, adding, or conditionally counting. You see, in the end, recursion is more than just a coding technique. It's a mindset. It teaches us to look at a huge, intimidating problem and just find that one tiny, manageable step that we can repeat over and over again until the whole job is done. So the question I'll leave you with is this. What big problem in your world can you break down into smaller, repeatable pieces? Thanks for joining this explainer.